Alright, what's going on, everyone? This is day 2 of coding every day. Right now, yesterday we did NeetCode 150. Today I believe I would like to still continue doing that. Hopefully I can make these YouTube videos a little bit longer, but the main purpose is to, code every day. But yeah, let's get straight to it. Yesterday we did contains duplicate, and today we're gonna do a what is this? A valid anagram. I've done this before. It's been a minute. So RAS. Okay, wait. So given two strings S and T, return true if two of the string anagrams are anagrams of each other, otherwise return false. An anagram is a string that contains exactly the same characters as the other string, but the order of the characters can be different. Never mind, I've never done this before. This, I thought it was like the reverse, like RA, like you could say like dad, like, and you reverse it, and yeah, a whole different. Let's see. Okay. Okay, this is gonna be hard for me. I don't even know how to like start this, but something that I've been seeing and I think I should do as well is go to this thing. No, not draw.io. Holy shit, it's Excel draw. There you go. Yeah, just write down some stuff to see if it helps or not, So how the hell? Okay, this is gonna be kind of tricky because I don't know where to start. I don't want to click the hints because using hints kind of suck. So obviously there's gonna be some type of data structure, but I have to use this. A brute force solution would be to sort given strings and check for their quality. This would be an so through the solution successful, you make a better way. I don't know how to do this. I don't know where to start. First of all, before we continue, I just would like to go to YouTube and see my past video because I think we did decent. I'm not. Where do I go? Jeez. Let's view my channel. I got 20 views, which is my most viewed video on YouTube. So yeah, I'm kind of happy. Click the link. Works. Cool. Yeah, I don't know. I don't know how to start this, if I'm being truly honest. Alright, so the way I'm thinking is like, RACE car. So you gotta do, so there's CC. Okay, this is OD, but like that takes so long. Holy shit! Like thing is, it's like, fuck, I don't know how to start this, bro. Hold up, guys. I need to get something. Where the hell is it? Oh, there it is. Stupid basketball. So how... Now this would be a good thing to do on stream, but I don't know how to fuck to. So obviously S and T are there. By the definition of anagram, we can rearrange the characters. Does the order of the characters matter in both strings? Then what matters? Okay. By the definition of the anagram, we can rearrange characters. We can rearrange the characters. Does the order of the characters matter in both strings? Does the order? Oh, it doesn't matter. By then we can rearrange the characters. Does the order of the characters matter in both strings? It doesn't. It doesn't. Then what matters? What matters is if. What matters is if the string contains the same exact characters as the other string, right? We can just consider maintaining the frequency of each character. We can do this by having two separate hash tables for two strings. Then we could check whether the frequency of each character is in string A is equal to so like do it. Okay, I'm gonna ask ChatGPT for a hint, because I don't know how to start this, being honest. Please give me a hint and do not give me the answer. Mind you, I only know basic Python. Let's delete this. Think about how you can compare the letters in both strings regardless of the order. Okay, think about it. Okay, the way my head is like thinking about it is that, okay, S is equal to 1. Now you go to the next one. You know what I mean? Okay, so let's R1, A1, C1, E1, C2, A2, R2. And now you check if the numbers on this side is the same numbers on this side. If two strings are anagrams, they must have the same length, obviously. Now the same letters with the same number of occurrences. Okay, let's just say this. Let's just say word S empty list. Well, start by asking, is there a way to count characters in each string? How can you compare those counts? That's why I pulled this up, because I'm not very good with dictionaries. Is there a way I can do A, B, C, D, E, F, G? Okay. Okay, I don't know if this is the efficient way to do this, but let's just go right here. Let's just write down what we think. what my thought processes are. So one, we know that they have to have the same length, right? If not, that equals to false. Holy stuff. Alright, false. False. That's one. That's easy. I think I can do that. Now, two. We should. Okay, if we make a dictionary with the alphabet. Okay. So what I am thinking is that I have a dictionary. And I have all the alphabet. No, I split the letters in the string for both. So what I'm thinking is I have a dictionary and I split the letters in the string for both S and R. Wait, S and what? What's the other one? S and T. Then I append the letters to the dictionary one by one, and if the letters and one by one and the letters should have, for example, race car goes R in a dictionary. How does it look? It should have a key and a value. It goes key is equal to A is R and the value is equal to 1. Then we move on throughout the string. Value 1, then we move on throughout the string, and the values go up +1 when there is another letter in the same word, like R would equal 2 and A would equal 2 and C would equal 2 and E would equal 1, and then compare it to the other dictionary T to see if it is the same. This above is my thought process. I would like you to give me a hint on if it is correct. Don't tell. Holy moly, too much typing, man. No, don't tell me the fucking answer. Instead of a pen, you'll increment the count. Actually, fuck it. Okay. Instead of a pen, we'll just do +1. I see how it, I already get it. Yeah. Like this. Then do the same for both S and then compare the two lectures. If they match, you find an anagram. Okay, so. Okay. So first things first. I need to split. So S is a string. I need to split these. Okay. So for okay, obviously I need a split underscore S is equal to this. Copy, and now split T. So for if I do, how do I use split again? I know it's S, so S dot split string apple, banana, orange. String. So string dot split. Oh, okay. So we don't really need this. We could just do split is equal to S dot split. If I print lit.s, huh? Fuck, I want to see if this is coming out correctly. Empty separator. Huh? Return split. Oh shit. I know, but I need to know. Hold up. Bro, watch out, bro. Oh fuck. fuck is happening, bro? I'm so confused. Like, why is it not splitting? Uh, 4 character. If I do 4 character, then how about if I'm quiet, guys? I'm just thinking 4 character in S. Four character in S. Four character in S. No dot append. No dot append. Character. There it is. That's what we need. We need to split that like that. I guess we could do this. Where are we at? We're over here. I'm just gonna do it new. I'm just gonna do it myself. So equals this. No. For character and new S and fuck, I gotta do 2 for loops. For character in S. We're gonna do new underscore S dot append character, and then we're gonna do for character in T, where we know T, boom. Equal to dumbass. Alright, split it. This works. So we split them. So now we split them. Okay, so now we split them. We can so we split them. Now I don't even think you need this. So for character in S, I guess. If how do you check the length? If okay, we could do if okay. We could do 0. This is gonna check if the length is the same or not. So for our character, we want to do news s plus equals 1. And copy. And boom. Is this correct right here? Holy shit, this is not correct, man. New T. Okay. If new does not equal new underscore T, then return false. Return false. Let's just run this. It's gonna be wrong, but your output, wait, but expected type as well. Your output is none, but Boolean's right there, you fucking idiot, bro. Okay, let's see. So this is what I have so far. I am checking if the length are the same or not. Checking the length are the same or not. If it isn't, then the anagram returns false. That's all I have so far. Don't give me the answer. Just tell me if I am doing it correct. If I am doing it correct, and a hint on what to do next. Don't show me code. Yes, you're doing good. So manually cut the length of the website. Checking out the length of your smart early exit. That's a good step. Hint on what to do next. Now that the lengths match, start building your frequency. Okay. Why is it saying this? Oh. Hey, okay. Okay, I get it now. It's looking for two booleans because... Hey, okay. Cool. So I guess this works. Oh, excuse me. Okay. So smart learners does not. Now that the links must start by building your frequency dictionaries for SNT. You want to track how many times each character appears on each string. So now that the lengths match, start building your frequency dictionaries. Okay, the dictionary parts is what I am.
Hey everyone, welcome back. If it that it works.
That's what it's called. So I hash it. If so, for n in nums. What was the shit again? If there's more than one array, otherwise false.
Hey everyone, that it works.
So the way we did it was we did hash it. So if n in hash it, return true. Otherwise add. So if I do hash set s is equal to this, that's how it was set. And then, holy shit, I didn't mean to do that. And I do this hash it t. So for letter in S, no, for letter, no, for letter in S, hash set underscore S. Is it add? Is that what he did? Dot add, you add it into it. So you add S. I'm so curious on if this works or not. Oh my god, bro, why you gotta do this? So for a character in S, add. So what if I say print hash set S? What would happen? Hello. Oh, why did I put S? I meant character. Add character. For a character in S. Add character if char does not if the character, which is the key, is not in. Yeah, if the character is not in, if character in hash set S. So if character in hash set S, we would like to just do hash set honestly this makes more sense if I do a dictionary, bro. I'm sorry, I'm not getting that set thing yet. I gotta learn it more. So if character okay, the way we're doing it right now is we're getting each character for characters. If character in hash set, if character not in hash set, if character's non hash set, we would like to add that character, that value in the hash set, and the way to do that is to do the way to do that is we get the hash set underscore S, right? We do this and we get the character is equal to that, yeah, so it's equal to 0. Oh no, it's equal to 1. It's equal to 1. Else if character in hash set underscore S, if it's already in that, we're gonna do this. We're gonna do +1. Yeah, exactly like this. Exactly like this. Oh, this one made it a little bit easier, but I guess this will work. I guess this will work. So if we do this, let's copy this. Now, for a character in T, character is not in T, T, T. So now, okay. So what we're doing now is we're checking. By the way, this I'm gonna delete after. I don't need this no more. I can just do and this. So for character in S, we're getting each character. If character is not in the hash set S, which is empty, it's just gonna make it 1. But if character is in the hash set, then we're gonna do hash set character plus equals 1. And it's just gonna add more. Now we have to compare. Let's just see what ChatGPT says. How does it look so far? Don't show me code, just hints. In your second year checking her? Well, did I do a mistake here? For a character in T, if character is not in hash set T character, oh shit. That's an issue right there. Anyways, what hint do you got me? You're missing the final step. After both dictionaries are built, you need to check if they're the same. That's how you determine. Okay, how the hell? I don't even know how to check if they're the same. How do you compare dictionaries in Python if you have to? Holy shit. You can just do equal. If hash set underscore s hash, I spell it right, set underscore s is equal to hash set underscore t, return true, else elif and hash set underscore s does not. Okay, I want to do this because there's two things you have to check. If they do not equal to each other, hash set underscore t, or the new, if this, boom. So I can get rid of this now, right? Or this, we're gonna return false. Moment of fucking truth, guys. Holy shit. No way. Let's go. Obviously, as embarrassing as it is, if anybody's watching this, I need to search up shit. I'm not very good with like. That's the point of this, is to do the problem solving, which I tried, but I'm getting there. I'm trying to get better at this. Some of these things I figured out on my own, but I don't know. I'm trying to get better every day. That's the point of this. But yeah. Let's see, what is an Uber interview question? Nice.
Hey
let's
everyone,
see
welcome back, and let's
what he
write-
has to say. Let me put my mic on. How long is this video? 12 minutes. Alright, hold on a second.
some more neat code today. So today let's solve the problem valid anagram,
Alrighty.
and we're actually going to be solving this a few different ways, so maybe you will learn something today. So we're given two strings S and T, and we want to return true if T is an anagram of S, or basically if both of the strings are anagrams of each other, and false if they're not anagrams. So main thing that they don't mention in this problem is what exactly is an anagram. And basically, it means that, you know, to call T an anagram of S is basically saying that using the characters of S, all of the characters, right, every single character, we can create the string T. So basically, they're made up of the exact same list of characters. So the string S, you can see that it has 3 A characters, 1 N character, 1 G character, 1 R character, and 1 M character. So it's made up of, in total, 7 characters. So that must mean that if T is an anagram of S, T has to have exactly 7 characters as well, which clearly it does have 7 characters, but are they the exact same characters as I wrote up above? Well, let's check. Okay, does it have 3 A characters? 1, 2, 3. Yep, it has 3 A characters. Does it have a single N character? Yep, it has exactly 1 N character. Does it have a G character? Yes, exactly 1 G character. Does it have an R? Exactly 1 R. It has exactly 1 M as well. So it has the exact same characters and the same quantity of each character. That's also important, right? Because 3 A's have to exist in T as well. So in this case, they're anagrams. We can return true. That's great. Second example, rat and car. Both of them have an R. Both of them have an A character, but one of them has a T while the other has a C character. They're both the same length. They're both length 3, but they have one differing character.
That's exactly why I just I just moved this here and I said or. That was my thought process, but let's go back to the video.
So they're not anagrams. We return false in this case.
Different
So the
solutions?
first solution I wanted to talk about is probably the most obvious one, and probably by just listening to me talk about anagrams, you might be able to come up with this by yourself. We just want to count the occurrences of each character in both strings, right? What's the easiest way to do that? Well, you could use an array or a hash map. That's what I'm going to use. I like hash maps. Basically, what the hash map is going to look like. So basically, we're going to have 2 hash maps, one for each string. And the key value in the hash map is going to be the character. So for example, A in string S, right? Let's use a different color. So A in string S. So how many A's are there? There's 3 A's, right? The value is going to be the count. The key is just going to be the character. We're going to do that for every single character in the string. So that's A. N has 1. G has 1. R has 1, and M also has 1, and we know that T is the exact same, right? It has 3 A's, 1 N, etc., etc., right? I could continue that.
Alright, watching this, it makes me think that, look, I don't really need this shit right here. I don't need to do that. This already does it right here, so I could just put news, this, right down below. And I think it would do the same shit. There is no point of these 2 for loops. Because these for loops just get each character in the word, in the string, and then I'll just add it. So that's less of a hassle. When you look at the solution, it makes you change your perspective on how to
so
solve
in the
it.
end, you can see that they're the exact same hash map, right? And once we've built these hash maps, we can then go through the keys and then compare that the counts for each character are the exact same, which in this case, yes, it is. So then after that comparison, then we know that they're anagrams, then we can return true. And how exactly I'm going to do that is I'm just going to actually iterate through the keys of one of these. So in this case, for example, I'm just going to iterate through all the keys in string S. So A, N, G, and then make sure the counts, right? We want to make sure that the count of each of the characters is the exact same. And if we make sure that both strings have the exact same length before we actually do the hash map stuff, then we actually only have to iterate through one of the hash maps and comparing it to the other hash map, right? Because if we make sure that T has exactly 3 A's, T has exactly 1 N, T has exactly 1 G, etc., etc. If we make sure that all of that is true, and that's
basically what I did,
then we pretty much know T is exactly the same as S because they have to be if they are the same.
I don't get that hash map thingy though. That's why I made the dictionary.
This is big O of N, or rather, let's say big O of S plus T, because we're going to have to iterate through both of the strings. So that's the time complexity. The memory complexity is the same. We want to make sure that the length of both strings is exactly the characters in both of the strings. Let's jump into the coding solution of this hash map solution that I'm talking about. Okay, so now let's code it up. And like I mentioned, a main thing we're just going to be doing is counting the characters in both of the strings. So we're going to create hash maps for that. This is how you can do that.
Like, I guess you can just put like the two variables right here and then the dictionary right there. So a hash map in the thing is like the last solution he did was with a hash map equals something, like it's just
Python,
weird.
But remember, before we even do that, we want to make sure that the length of both strings is exactly the same, because if they're not the same length, then of course it's impossible for them to be palindromes, so we can immediately...
Bro, I could have just saved this shit right here, bro. Holy shit, I could just put if... like... if the len S is equal to, then else. Oh, fuck.
Whoops. Then we can immediately return false if they are not the same length. Otherwise, we can actually run the algorithm. So let's just go through the strings at the same time. So
range.
We can iterate basically through the length of the string S because we know they're both the same length. So we can just use the index I for both of the strings. Count S is basically going to count the occurrence of each character in string S, of course. So each time we see a character, so a character is basically going to be S at index I. That's the key of the hash map. Every time we see a character, we want to increment the count of that character by 1. So can we just say 1 plus this? Can we just say 1 plus this? Well, in Python, no, because what if that character...
What the fuck is going on? Count S bracket I
doesn't even exist in the hash map yet, then this is going to throw a key error, right? Key does not exist. So to get around that in Python at least, there's a nice little function with hash maps that you can use that's called get. So get this this key, and it'll basically do exactly what's being done over here on the left side, but the second parameter to this function is basically a default value. So 0 is the default value in this case. That means that if this key does not exist in the hash map, then the default value that this function is going to return is 0, which is of course what we would want it to return, right? So with this line, we're just counting the occurrences of each character in string S. We can do the exact same thing with string T, just by copy pasting this and then changing everything to T. So making sure we use the T hash map and making sure we iterate through the string T, right? T at index I. So that's pretty much it for building the hash maps. Next, we want to iterate through the hash maps and make sure the counts are the same. So let's say for C, for the character in count S, so we just want to make sure the counts of both hash maps are the same. So count at character I is equal to count T at character I. So the counts are the same. Actually, in this case, we want to make sure that the counts are not the same, because if they're not the same, then we basically know to return false immediately, because then we know that they're not anagrams. if you have noticed, we're iterating through the keys in Python. At least we're iterating through all the key values of count s, right? The count map of string s, and c is going to be the key. But what if that key does not exist in the t map, right? Count t. What if it doesn't exist in this map? Well, again, we can use that default
at the
function
data structures
of
point yet,
get,
but
so that it doesn't throw a key error for us, and it'll return a default value of 0. So that's basically the entire algorithm, right? We built the hash map, we performed the check, and then if we never return false here, that must mean that they are anagrams. So then if the loop exits, we can go ahead and return true. That's the entire code. Let's run it to make sure that it works. So you can see on the left it does run. It's relatively efficient, though it doesn't reflect that on LeetCode. But basically, you can actually do exactly what I just showed you with one line of code, at least in Python. But I think this is kind of cheating, and it probably won't work in an interview. But counter is a data structure in Python, which is a hash map, but it basically counts things automatically for you. So we can run a counter on S, and we can run a counter on T, and if these counters are exactly equal, basically by doing the equal sign, I'm just doing what I did down here, right, with the for loop, but the equal sign does it for us instantly, so it does that, and then we can just return the result. If they're equal, it'll return true. If they're not equal, it'll return false. I can run that. The solution is actually simpler than you might think. Just kind of thinking about how anagrams work. If you took all these characters and put them in a hash map where we can count the occurrences, then it's pretty easy to check if they're equal. But isn't there another way? What if we made sure that the characters show up in the exact same order every single time? What do we mean by order? Well, one possible way would be sorted order, right? Because if they really are the exact same characters, then if we put them in sorted order, then they should actually become the exact same string. Then we can literally just do an equals operation on both of the sorted strings and guarantee that they're going to be equal. But the downside is, what's the time complexity of doing sort? Well, in some cases, with bad sorting algorithms like bubble sort or something, it might be n squared, right? Good sorting algorithms can do it in n log n time, right? Worst case, big O of n log n time. But the space complexity is kind of iffy. Usually sorting algorithms, at least good ones, actually do use extra memory. They use O of n extra memory, but sometimes they... But I really hope that this was helpful. If it was, as the two previous solutions that we came up with below. And who knows, maybe your interviewer will return false. Let's run it to make sure that it works. And on the left, you can see, yes, it does. It's relatively efficient. But technically, it's not as efficient as the two previous solutions that we came up with.
Okay, I'm so curious on
what I just showed you with one line of code, at least
on the difference. Okay. Explain to me the difference between my code and the image. You're both checking the length. Okay. Character counting, comparison. Differences. You're manually looping through string increment. Yeah, I know. I should have done this. Final comparison. Damn. So you need to check again. Suggestions, use len. That is actually something I should have used. Instead of if character not in dictionary, shorter, more elegant. Okay, well, I don't know. Whoever's watching this, I'm kind of proud. It's not that bad. There's things I would have done different, like this. I would have not have done that. This right here I would have done. I could have just put in the for loop. Or fuck all that, just do the len. The length is the same. Whatever. For the next video, I think I'll just take a break from the Necode. So tomorrow I'll take a break from the Necode. I think I'll be doing a you know, just a little revisit on everything here, just try to get a little bit better, and then see what else I should be doing. But whoever's watching this, I appreciate you for watching and sticking to the end. It means a lot. I know I didn't talk much because I was thinking, but next time I'll try to think more out loud. So yeah, I appreciate you for tuning in. Yeah, means a lot. So yeah, see you.